Hello, we are Group 1 and today we are going to discuss about Chapter 16. Our group include Minh Hoàng, Đắc Hưng, Quỳnh Giao, Lê Minh and Minh Phương. So, let's start off by knowing what quadratic graphs are. Basically, they are graphs with U or reverse U shape, otherwise called parabola, and they also consist of a squared term such as x squared. Some examples of these are y equals x squared, y equals x squared plus 5, or y equals x squared minus 3x, or y equals x squared plus 5x plus 6. This here is an example of what the graph will look like. The equation of this is y equals x squared plus 5x plus 6, and we can see that the graph is a U shape, so we can identify that it is a parabola. Some common mistakes that people make are drawing the curves too far apart, which makes them wobbly, drawing them into small sections, which leads to feathering, or making their turn, or otherwise called bottom, really flat, which makes them hideous, or plot the points wrong, which makes the graph look out of place. Here are some exercises that we are going to go through to have a better understanding of this. First, we need to draw the graph of y equals x squared plus 2x minus 3 for minus 4 smaller or equal to x smaller or equal to 2. The first step to solving this is drawing a table. It says that we need to find the value of x from minus 4 to 2, so that's what we are going to put in the first row. In the second row, we are going to write the equation for y and then use the value of x above to find the value of y. With the results that we have found out above, we can plot the points in and then draw the line, which is like this, a parabola line. B. Use the graph to find the value of y when x equals minus 5. So this is really simple. The first thing that you need to do is to find out where x equals minus 5 is, which is right here, and then use a ruler to draw a straight line from there up. Next, we need to locate where it crosses the parabola, which is right here, and then draw a line from there to find where it crosses the y-axis, which is 12 in this case. In conclusion, we can say that y equals 12 when x equals minus 5. So, welcome to chapter 16.2 about turning points on a quadratic graph. So, the fundamental knowledge that you should know is that the turning point is where the graph changes direction. For example, right here, the turning point would be here because that is where the line changed from declining to ascending. So the way that you know where the turning point is by using the completed square method. So for example, y equals x squared minus 6x plus 12. We need to turn them into completed square form in this way. So we turn them into x minus 3 to the power of 2 plus 3. And we can see that x minus 3 to the power of 2 equals 0 when x equals 3. So the turning point of this graph is 3.3. The first 3 is because this, and the second 3 because of this. Now we're going to go through some exercise. First, write y equals x squared minus 2x minus 8 in completed square form. We turn x squared minus 2x minus 8 into x minus 1 to the power of 2 minus 9. Then find the coordinate of the turning point. We can see that this is minus 9, so this will be the y point, and we can see that x minus 1 to the power of 2 equals 0 when x equals 1, so the turning point is 1 and minus 9.
In 16.3, we will discuss about reciprocal graph. First, a reciprocal equation has the form of y equal a over x. For example, y equals 2 over x, y equals minus 7 over x, and 15 over x are reciprocal equations. In example 2, we will have a small exercise. Complete the table to draw the graph of 2 over x for minus 0.8 less than or equal to x less than or equal to 0.8. Here I have the complete table, but remember to round the values to 2 decimal places, and there's no value for x equals 0 because 2 over 0 is undefined. And after that, plot points on the graph and we'll have the complete graph here for 2 over x with minus 0.8 less than or equal to x less than or equal to 0.8. In 16.4, we will learn about cubic graphs. Cubic function or graphs contain a term in x cubed. For example, y equal x cubed, y equal x cubed plus 3, y equal minus x cubed plus 4x squared are cubic function or graph. Example 2, we will complete the table to draw the graph of y equal minus 2x cubed plus 5x squared minus 8 for minus 3 less than or equal to x less than or equal to 3. Here is the complete table, and from that we will plot points on the graph, and here is the complete graph for y equal minus 2x cubed plus 5x squared minus 8 for minus 3 less than or equal to x less than or equal to 3.
This is chapter 16.5, exponential graph. Now first of all, we must know the exponential equation, which is ft equal I multiplied by 1 plus r in the brackets to the power of t. T is time, I is the initial amount, and r is rate. Now look at the example over here. There are 2,000 monkeys in the forest. Scientists said that the numbers of monkeys increase by 40% each year. Draw a graph for numbers of the monkey in the next 6 years. The rate here is plus 40%, which is plus 0.4. The equation is 2,000 times 1 plus 0.4 to the power of t. It is recommended to write the exponential equation out first before plugging the numbers in. We will have this table over here where t is equal to 1, 2, 3, 4, 5, 6, and ft is equal to 2,000, 2,800, 3,920, 5,488, 7,683, 10,756. Therefore, we can draw this graph over here. You can see that the line is going up, but it is not a straight line. This is called exponential growth. The next thing we are going to learn about is exponential decay. The equation is a little bit different. ft equal to I multiplied by 1 minus r to the power of t. Look at the example over here. Atmospheric pressure is measured in HPA. At sea level, the pressure is 1000 HPA. It decreased by 12% for each kilometer increase in height. Draw the graph for the 7 kilometer increase in height. We can see that the rate here is minus 12%, which is minus 0.12. We have this equation over here, 1000 times 1 minus 0.12 in brackets to the power of t. And therefore, we will have this table over here. T equal to 0, 1, 2, 3, 4, 5, 6, and 7, while the corresponding ft is 1,880, 774, 681, 600, 528, 464, and 408. And we will draw this graph over here, which you can see that the line is going down, but it's not a straight line. Once again, this is called exponential decay. Moving on to chapter 16.6, estimating gradient. Not every graph is a straight line, so we can't always use the exact method to calculate the graph gradients. For example, this graph. You can see that it's not a straight line at all. So instead, we can estimate gradient of any point on the curve by draw a tangent at that point, which is a straight line that touches the curve at that point, and calculate the gradient using a triangle. Now look at the example over here. Find the gradient of point P, where x is equal to 7 and y is equal to minus 1.5. The first step we should do is draw a tangent at the point P. And then we'll draw a triangle and find the difference between x and y coordinate, which is 3 and 3. The gradient is equal to difference in y and difference in x, which is 3 divided by 3 and equal to 1.